Yeah, so today we're going to start with the fluid dynamics. من اسمه مثل ما نقدر نعمل guess, we are going to study the fluids. So we're going to define first the fluids and the dynamics as well. So first of all, a fluid is a collection, we can see it, it's a substance made of material, made of molecules. And these molecules, they are randomly arranged and they are held together by the weak cohesive forces, okay, and the forces exerted by the force of the container. So the fluid in general is a material, it's a substance بالأحرى مش material, it's a substance which doesn't have a shape and it takes the shape of the container where it is, and both liquids and gases are fluids in general. So we will be studying fluids in terms of liquids and gases, and we will study two cases. The first is when a fluid is at rest, and this is what we call the fluid statics. And we will also study the fluids in motion, and this we call it the fluid dynamics, okay? So here we will start with the fluid statics first, and once we are done, we will move to fluid dynamics. But both fluid statics and dynamics, they are one chapter in the book, which is the chapter number 14. So let's start first with the pressure. So as you know, a given fluid, it exerts a pressure on any object that is submerged or immersed in it. So let's say if you just imagine that we have a container, and in this container we have a given object. So let's just draw here. This is a container. When we say a container, يعني أي recipient موجود فيه الفluid. شو ما كانت الform تبعه, we don't care. So if you just consider a container, and let's imagine that you have a given object in this container, in this fluid. So actually the fluid will exert a force on this object from all sides. من كل النقاط اللي the object is in contact with the fluid, it will be subject to a force exerted by the fluid on the object, and this force is normal, which means perpendicular to the object at any point. So that's number one. Number two, this force, it could be translated, يعني بنترجمها عمليا بpressure. But what is the difference between the force and the pressure? الفرق الوحيد انه البريشر هي نفس الفورس بس divided by the area of contact, the surface area of the contact between the fluid and the object. So if you take, for example, on this side, you can define the pressure exerted by the fluid to the right on this right side of the block, for example. Consider that you have a block. You have to keep in mind that the pressure defined as the ratio between the force and the surface area is a scalar quantity, which means that it's just a number. Okay, it doesn't have any orientation or direction in space. You have here what we call the dimensional analysis. احنا بهالطريقه عاده نقدر نعرف شو هي اليونت لجيفن variable. مثلا مثل بهالحاله نقدر نقول انه اليونت للبي هول البراكتس بيعني انه نحن عم ندور على اليونت للبي is equal to the unit of the force F divided by the unit of the area. So it is Newton, which is the unit of the force, divided by meter squared, which is the unit of the area. And so we can say that the international system, the unit of the pressure, it's given by 1 Newton per meter squared, which we called Pascal. So usually pressure is expressed in terms of Pascal, and 1 Pascal is 1 Newton per meter squared. So this is it. This is about the pressure. This is what we need to know about the pressure along this chapter. Now let's move on to discuss the variation of the pressure with the depth. This is a very important, not application, but it's a very important concept in here that we are going to use extensively in the chapter بشكل مكثف من خلال relation حنطلعه هون. Let's take kind of an exercise, okay? We have a recipient here, a given container that contains a given liquid at rest. And this liquid is of uniform density, meaning that the liquid is not compressible at any point. It's incompressible. لما نكون نحكي عن liquid or fluid in general of uniform density, نعني فيها إنه هو incompressible. You cannot compress it. إذا بتعمل له compression, هل exceed بريشر رح ينتقل لمحل ثاني، هو حينقله لمحل ثاني، وبالتالي اذا كانت البريشر كثير قويه مثلا in a given container ممكن يتكسر الكونتينر لانه هو ما بيحمل هالضغط لانه incompressible. وعمليا mathematically speaking it means when we say a liquid or a fluid is incompressible يعني rho is equal to a constant, which means if you take any portion of the fluid inside the container, you measure the density at these points, you will end up with the same value. So let's consider this fluid in this container. Let's select a sample of liquid in an imaginary cylinder of cross-sectional area A. So in other words, let's consider that we are going to select some portion of the water be a given cylinder, عنده cylindric shape, okay? And we want to discuss what happens at the walls of this cylinder, okay? So when we say cross-sectional area A, it means the area of the circle of the cylinder. يعني مثل ما بتعرفوا السلندر هو عبارة عن circle, okay? And it has a given height. يعني عمليا هيدا السيركل بيتكرر h مرة, okay? So you have a circles on top of each other. هدول بيعملوا cylinder. فالcross section مو cross sectional area A, it means the area of the circle here. This is A. Okay, so this is A. Now, what we want is the following. We want to determine an equation, okay, that relates the pressure at the top face of the cylinder with the pressure at the bottom face of the cylinder. So let's call P the pressure at the bottom face of the cylinder, and let's call P0. You can call it anything, this P0, okay? We just call it P0, the pressure at the top face of the cylinder. Let's say that this P0 is known. هيدا بنعرف شو هي. This is known. But we want to determine P, the pressure of this fluid at the point here, at the bottom face, okay, من خلال P0. So that's what we are going to do. Let's try to do it. هدفنا نجيب relation ما بين P P0. Let's have a look at this cylinder, what happens. So the force exerted by this cylinder, as we have discussed earlier, the fluid exerts a force on each side of this cylinder from top, bottom, left, and right. So they are all in equilibrium. The cylinder is in equilibrium. So let's consider the y direction to see what happens along it. We have F bottom, so FB to say for bottom, which means the force exerted by the liquid on the bottom face of the cylinder. This is equal to the pressure multiplied by the area, cross-sectional area. هيدي من وين جبناها؟ جبناها من definition للpressure نفسها اللي هي P equals to F divided by A. So the force is equal to pressure multiplied by A. So FB, it's the pressure at the bottom face multiplied by A, والpressure at the bottom face هي قلنا equals ل P. So انتبهوا هون بس هذا الارو لحتى نقول انه هون الpressure at this point هي P والpressure at this point هي P0. هول منهم forces، هون الforces مرسومين. And we have F top. So on the top face, we have the force exerted by the fluid is given by P0 multiplied by A. Now let's apply Newton's second law on this sample. So this sample is in equilibrium. The fluid is at rest, and this sample is in equilibrium, which means that it is not, it doesn't have any motion. So that's why AY is equal to 0. What are the forces acting on the vertical direction? We have minus FT plus FB minus mg is equal to 0, where we have taken the y-axis to be pointing upward. You just put each term by its value, we end up with طيب ال ft هي minus p0a صارت plus p times a minus. Now m, we don't know what is the value of m, but we can relate the value of m to the rho and to the height of the cylinder. So we can write down m هي على طول rho times v. كمان هيدي it's another concept that I want you to all the time keep in mind. لما نحكي عن mass، لما نحكي بالميكانكس عن mass، بالنسبة لنا الماس هي مجرد رقم which enters in the weight usually. لما نحكي عن fluid dynamics, it's also the same. I mean, the mass is at the end. It measures the quantity of matter that we are looking at. But keep in mind in fluid dynamics that the mass is related to the rho, the density of the object multiplied by the volume. لأنه خلوها ببالكم لأنه ممكن تعوزوها كتير. So if we write down m as rho times v, the volume of the cylinder is given by the cross-sectional area اللي هي عمليا كأنه عم نقول نحن هيدي المساحة وهي مضاعفه كم مره؟ مضاعفه h مره. So the volume is nothing else than A times D. So it's the cross-sectional area multiplied by the height. So we can now simplify A in all terms لأنه موجود بكل الترمز بنقدر نختزله. We end up with P minus P0 is equal to rho times G times H. So what does it mean? It means that if you have a given container and you know the pressure at a given point and you want to determine the pressure at another point, إذا عندكم أنتم point, let's call it point B مثلا. هذه بسميها point B أنا. لا let's سميها yeah, this is point B for bottom and this is T for top. Okay. أنا إذا بدي أجيب البريشر على البوينت B بتطلع شو في فوقي عمليا. So we have the closest point where the pressure is known. أقرب نقطة بعرف عليها البريشر هي T. So بقول فإذا هي البريشر على النقطة T plus the pressure exerted by this column of water out of liquid on top of the point B. So فإذا هو الضغط على هالنقطة اللي فوقها زائد الضغط اللي عم بشكله هيدا الكولوم of fluid، هيدا الكولوم of liquid. So هل الضغط is equal to rho times G times H where H هو طول هيدا الكولوم. Okay. So this is number one. Number two. هل fundamental relation of hydrostatics that we call هيدي اللي بنسميها fundamental relation of hydrostatic P equals P0 plus rho GH where P0 is the pressure known at a given point on top of the point of interest. كمان بتقلنا انه اذا بتاخذوا اي نقطتين at the same level, let's say if I take at this here, I take this level and I take 2 points او مش هيدا رح اخذ البوتtom face. عموما اذا بناخذ هيدا الليفل if I take any 2 points okay او any points along this, all these points they have the same pressure لانه اثنيناتهم او كلهم على نفس الغمق، كلهم موجودين على غمق H under this level اللي هو P0 اللي هو كمان هون اذا بتاخذوا اي نقطه along this level you will end up with the same value of the pressure اللي هي P0. Okay, so this is the second message from the fundamental relation of hydrostatics. And what does it mean in terms of words? It means that the pressure at a given depth H below a point in a given liquid at which the pressure is P0 is greater by an amount times rho GH. يعني إذا بتاخذوا أي نقطة okay where بتاخذوا نقطة ثانية بتعرفوا عليها البريشر to be P0 وهالنقطة اللي أنتم بدكم تاخذوها هي تحت منها تطلع إنه البريشر عليها هي البريشر P0 زائد الكوانتيتي rho GH where rho GH is the pressure exerted by the fluid okay on top of the point you are looking at and between the point you're looking at and the point where the pressure is known. So هيدا بكل بساطة I would say the fundamental relation of hydrostatic. Of course, from out of this section, all what you need to know is that if you have a point, if you have a given container, and you have a point بغمق معين, let's say, نقول إن أنتم عم تطلعوا على هالcontainer, okay, هالcontainer up into the atmospheric air. Number one, إذا كان الcontainer up into the atmospheric air, you will have P. Here I will call it P0 to say P atmospheric. So P0 بهالحالة هي P atmospheric. إذا كانت هالنقطة على غمق H فبتقدروا تقولوا إنه P هي بهالحالة P atmospheric plus rho times G times H. Okay. So here I've just said also one more comment is that when the liquid is up into the atmosphere, so the container يعني اللي فيه liquid is up into the atmosphere, the pressure at the surface of the liquid is equal to the atmospheric pressure, which is given by 1.013 10 to the power 5 Pascal, or sometimes it can be we can use 1 atmosphere, but in general in our case we are going to take the Pascal to be our unit. Okay, so this is it for what concerns the fundamental relation of hydrostatic, and out of this section all what you need to know هي هالrelation اللي هي انه P equal P0 plus rho GH, where P is the pressure at the point you are looking at, P0 is the pressure at the point that you know what is the pressure on يعني عمليا plus rho times G times H. بتطبقوها مباشرة وهيدي بس اللي بتاخدوها من هيدي السكشن. كل شيء هون بهيدا الفلويد رح نعمل يعني رح نشرح بكل سكشن كيف بنجيب الريليشن، بس انتم بس مطلوب منكم تفهموا كيف وصلنا لها، بس مطلوب منكم تستخدموها بشكل مباشر مثل ما هي بالريد بوكس. So this is it for the pressure, the variation of the pressure with the depth. I'll take your questions at the very end, so please keep your hand raised. Let's move on to another topic in the case of fluid at rest, which we call Pascal's law. Actually, Pascal's law, it's very simple in the sense that the message out of the Pascal's law is that if you have a given fluid in a given container, and if there is any change in the pressure applied to a given point on the fluid, this change in the pressure is transmitted undiminished to every point on the fluid and to the walls of the container. يعني عمليا إذا بتيجوا عندكم بكون container مسكر فيه بقلبه fluid, and then you بتضغطوا على البستن, for example, you increase the pressure, then this increase will transmit, راح يعني propagate, it will propagate undiminished من دون أي نقصان لكل نقطة بالفلويد. Let's take one application to make this easier and more clear. So one of the very famous applications in this case is the hydraulic press. What is the hydraulic press? I will give you an example before to start. حكيم اسنان, كرسي اللي عند حكيم اسنان بالعادة, as you all know, I mean, في كثير ناس بتطلع على الكرسي عند حكيم اسنان طبعا بأوزان مختلفة, بس الشيء الحلو انه حكيم اسنان بيقدر بمجرد ما يدعس على مثل مش كبسة, بس بيدعس على يعني على قطعة معينة بإجره, بيعمل بريشر على هيدا البيس, وبتلاقوا انه الكرسي عم تطلع حتى لو كان الشخص اللي قاعد عليها كثير كبير. So this is actually one example of hydraulic press. Another example عند الميكانيسيان عموما بورشات العمل, اوقات كثير بتلاقوا انه بكون عم بيطلع سياره, علما انه السياره وزنها كثير ثقيل, ولكن بيقدر بيطلعها بمينز of very very small force عمليا. كيف بيطلعها كمان, this is an example of hydraulic press. شو بيصير عموما بهيك حالات؟ Let's consider this kind of system. So you have here a container. This container is made of two tubes basically. The first one is a thin tube صغير عمليا, وبصغير بنقصد that it has a cross-sectional area which is very small. This is A1. Okay, and the other part of this container, it has a cross-sectional area A2 which is bigger than A1 and significantly bigger than A1. And let's assume first that we have this. So let's assume first that this was our system. Okay, this is the big tube and this is the thin tube. And what happens is that we have and those two tubes, by the way, they are connected through a channel. It's very thin channel. يعني عمليا هيدا الوصلة ما بين أول تيوب والثاني بيكون extremely small. So let's consider this to be our system initially. So هون كانت أول هيدا ال A1, هيدا الانبوت بنسميها عادة. Okay, and this is the output. So let's assume that this was the البستون هون كان بهيدا الليفل على الاوتبوت, وهون البستون كان على الانبوت بهالليفل. So what we do is that we exert here a force. بنجي بنضغط على البستون 1 with a given force F1. What happens is that this piston here will move down by a given let's say length or different displacement, I will call it delta x1, and the water or the fluid will become here, right? So هذا هون الشيء اللي بنقصده, انه هون البستن كان فوق ونزل لتحت ونزل هالديستنس او هالديسبليسمنت دلتا x1. كنتيجه لهالفعل بصير عندنا انه البستن on the other side will go up. So this piston will go from this point here, so from this level to this level, and it will make a displacement delta x2. And of course, delta x1 and delta x2, they are not the same. They are different because the cross-sectional areas are different. So what happens in this case? What happens is fully described by Pascal's law. When you exert a force here, F1 on the piston, on the small piston, this pressure is, force, it means that you have give the fluid an additional pressure. As you know, pressure is equal to F divided by A. So this F1, it results in a given pressure P1, which is equal to F1 over A1. فهالpressure, increase in the pressure اللي بصير انه it will be transmitted through this fluid and undiminished, يعني من دون ولا اي نقصان, to each point on this piston. فزيادة البريشر حتخلي انه هالبستون يطلع لفوق, Okay, and we assume, but we present this pressure F2 by a force F2, where F2 is equal to P2 times A2. So we associate with this pressure a given force, وكأنه في force عم بتشده لهالبستون through. So the goal here in this application is to find a relation between F1 and F2. Actually, the pressure is transmitted undiminished from the piston A1 to the piston A2. But because the pressure is the same on both sides, then we can write down P1 is equal to P2. But so this means F1 over A1 equals to F2 over A2, and we end up with a relation F2 equals to A2 over A1 multiplied by F1, which means that it's very important. If you apply a force F1 at the input, you will get a force F2 at the output, and F2 is as greater than F1 as A2 is greater than A1. كل ما بتكبروا ال A2 كل ما هالريشيو بيكبر، وكل ما بتصغروا ال A1 كل ما هالريشيو بيكبر. So انتوا بتقدروا تتحكموا بالفاكتور قد ايه بدكم تكبروا ال F2 مقارنه بالانبوت فورس F1 بانكم تتحكموا بال A1 and A2. So for a given hydraulic press, if you design it in a given way with the appropriate values of A1 and A2, you will be able to get a very large output force by the means of a small input force. Okay, so this is what you need to know from the hydraulic press. This equation you can immediately apply it in the exercises. F2 is greater than F1 by a factor which is given by A2 over A1. عقد ما ال A2 بيكون كبير عقد ما الفورس بتكون أكبر اللي عم تاخدوها على الاوتبوت. So that's the first equation. Now we can also relate, instead of relating F1 and F2 to the cross-sectional areas A, we can relate them to the displacement delta x1 and delta x2. How can we relate them? I will tell you. So here we said that the volume of fluid displaced هون اللي مشي هالقد اللي مشي أو نزل distance delta x1, this vertical يعني distance displacement عمليا هو نفس كمية الفلويد اللي اتحركت من تاني جهة delta x2, because this container is completely closed and you don't have any kind of liquid added or removed to the system. So definitely V1 is equal to V2. The amount of the volume of fluid displaced on one side is equal to the volume of the fluid displaced on the other side. How much is the volume of the cylinder? In the first part, the volume of the cylinder is equal to A1 times delta x1, and on the other side, the volume of the this volume going from the initial position to the higher position is equal by A2 multiplied by delta x2. Okay, so you end up with an equation relating A1, A2, delta x1 and delta x2. So you can write down لأنه F2 over F1 equals لا A2 over A1. Okay, then from A2 over A1 you can get from here an equation between A2. A2 over A1 is equal to delta x1 over delta x2. So we can find a relation between the forces and the displacement given by F1 multiplied by delta x1 is equal to F2 multiplied by delta x2. So F2 multiplied by delta x2. And this is it. Okay, give me just 1 second, please. Yes, sorry, so I'm back. And so we end up with an equation between the forces and the displacement. So here you can see it, I already have written it here. So we end up with F1 delta x1 is equal to F2 times delta x2. So here as you can see it's بالعكس هون F2 هون F2 over يعني F2 is equal to A2 divided by A1 F1 بينما هون ال F2 هي delta x1 over delta x2 times F1. ليش؟ انقلبوا لأنه ال displacement بالجهة الأرفع. So when A1 is smaller displacement بيكون أكبر. لأنه عندكم نفس كمية المي هون عم تتوزع على مساحه كثير ضيقه فبتمشي مسافه اكثر، بينما هالنفس كميه الفلويد هون عم تتوزع على مساحه اكبر بكثير على A2 اكبر، فبالتالي ما بتمشي نفس المسافه، بتمشي مسافه اصغر. So this is it for the Pascal's law and the hydraulic press. Keep in mind this hydraulic press as a very famous application of Pascal's law. Now we're going to move to the pressure measurements. So the pressure measurements are, we have different kind of instrument to make the pressure measurement. So the first one is what we call the barometer, is an instrument that is made such that we can measure the atmospheric pressure. So in this case, we have a long tube, okay, which is closed at one end, is filled with mercury, and it's inverted in a container of mercury. So here we are going to consider a few points. Let's discuss a little bit the system, what happens. So أول شيء عبينا mercury بهيدا التيوب وبعدين قلبناه بقلب هيدا الكونتينر. This container is open to the atmospheric air. So what happens is that this mercury with the mercury inside, they will keep moving لحد ما يوصلوا لمحل يصير في equilibrium. بس يصير في equilibrium هالمركوري رح ينزل، اوكي، وبالتالي هون رح يفضى this end of the tube. When you say that this end of the tube is empty, that means that there is a vacuum. شو يعني vacuum؟ يعني عبارة عن فراغ، يعني ما في matter. And when there is no matter يعني there is no pressure. يعني الpressure هي بتخلق من الماتر. So that's why in this end tube the pressure is equal to 0. Now the point is that we want to measure the atmospheric pressure. So let's write down a few equations. طيب نحن لما نقيس atmospheric pressure, so we need a point at the surface لأنه the pressure at the surface هي عمليا للatmospheric pressure اللي بدنا إياها. So let's take point B to be at the surface, and then let's take another point at the same surface يعني على نفس level of B. But this point is not on the surface outside the tube, but is inside the tube. ليش ما ناخدها inside the tube لحتى نقدر نجيب شو هي ال H. Okay, let's do it. So since these 2 points PA and PB, they are at the same level, we can write PA is equal to PB. But now let's check what are PA and PB. The PB هي atmospheric pressure that we are looking at, that we call P0 or P naught. And what is the pressure at A? According to the fundamental relation of hydrostatic, the pressure at point A is given by the pressure at this top point اللي هي at the top point هي 0. The pressure is simply 0. هي I will just write it down. هي عبين 0. Plus the pressure exerted by this column of mercury on top of the point A, according to the fundamental relation of hydrostatic. So it's given by rho of the mercury multiplied by G multiplied by H. So we just put PA equals to PB. بيطلع معنا قد ايه هي ال H. So إذا كنا بدنا نجيب ال H بتقدر تطلع معنا يعني إذا we fix the atmospheric pressure to 1.013 10 to the power 5 Pascal, then we can see how much mercury should we see in the tube to have this value of the atmospheric pressure, and بيطلع معنا 0.76 meters. So what when we usually use this barometer بنقيسه بالشكل التالي، بنشوف قد ايه الميركوري الهايت تبعوله بهيدا التيوب، and from this H we put it inside this equation وبنقدر نستنتج قد ايه هي atmospheric pressure, and of course vice versa يعني الحالتين مظبوطين. So another instrument also or system that we can use to measure the pressure is what we call the open U-tube manometer. In this case we have a U-tube. لما نقول U-tube we mean a tube that has the shape of a U مثل بهالشكل هيدا. So هيدا هو هون ال U-tube. It's open from one end يعني هون open to the atmospheric air. This is what I mean by P0. وهون موصول على another system. It's like a sphere and connected to this U-tube. So this contains a given fluid of unknown pressure, and so we want to measure the pressure of this fluid. And you have here some mercury, let's say. So the pressure exerted by this fluid, okay, رح تخلي المركوري يتحرك بقلب ال U-tube. So how to measure the pressure of this fluid? You take the point here, the point at the separation between the fluid, the two fluids. Okay. The pressure of the point at the point A هي البريشر تبع هيدا الفلويد عمليا. طب كيف بدنا نوصل هيدا الشيء بالهايت of the mercury on the other side? We have to take a point at the same level as the point A. اوكي، يعني اذا بتطلعوا على هي النقطه التحتانيه اللي عم بصير عندكم انه هذا الغاز اول ما تحط الغاز او الفلويد عموما شو ما كان، اول ما توصلوه باليوتيوب هيعمل ضغط من هي الجهه وبالتالي حيحرك الميركوري لفوق، فبضل يعمل ضغط وبضل هيدي النقطه تتحرك لحد ما يوصل للاكويليبريم. بس يوصل للاكويليبريم كله بصير طبعا واقف، وبالتالي هالنقطه كمان بتصير واقف. فاذا بنطلع من هي الجهه وبنطلع من هي الجهه البريشر هي نفسها على النقطه A وعلى النقطه B. So we write down the pressure at point A, which is the unknown that we are looking for. هي عمليا the pressure at point B. We apply fundamental relation of hydrostatic at the point B. We end up with so the pressure at the top اللي هي P atmosphere, P node, plus the pressure exerted by this column of mercury on top of the point B اللي هي rho times G times H. Okay. So a general comment. When you determine the pressure at a given point, okay, من دون أي تفصيل آخر، ونحكي عن absolute pressure اللي هي عمليا البريشر مثل ما بنقيسها كاملة من دون أي نقصان. When you are asked, so this is we call the absolute pressure. When you are asked to determine the gauge pressure, they mean by gauge pressure the difference between P and P node, which is the difference between the pressure and the atmospheric pressure. وكأنكم يعني بمعنى آخر بهالحالة عم بتقيسوا البريشر مش بالنسبة للصفر, so you're not looking for the absolute value, however you are looking for the for a relative value اللي هي قد زيادة أو ناقص بالنسبة للبي P0 اللي هي البي atmosphere. So this is what concerned the pressure measurements. This is it for this fluid status.